Over the last few years, decentralized finance protocols have been continuously drained for billions of dollars in user funds. The standard response to these massive losses is to blame human error. The diagnosis is usually that a programmer made a typo or an auditing firm missed a bug in the code. But fixing individual lines of code treats a symptom, not the disease. The actual root cause of these exploits is the architecture of Ethereum itself, a system known as the account model. The account model is a framework where all user balances are tracked as entries on a global master list. No amount of security auditing can secure a system where your digital ownership relies entirely on trusting that global list. The account model is vulnerable by design. When you buy a token on the Ethereum virtual machine, or EVM, you don't actually hold a digital object in your wallet. Looking at this animated diagram of the ledger, we can see how Ethereum actually stores value. Your balance is just a number mapped to your user address inside a massive, centralized spreadsheet. That spreadsheet is completely controlled by a third-party smart contract. To change that number, you have to authorize an imperative execution trace. This means you sign off on a specific step-by-step computational path to update the spreadsheet. Because you broadcast that exact path to the entire public network, attackers can easily intercept and manipulate the steps before the final numbers update. Because you don't physically hold your assets, you are forced to deposit your money into these shared ledgers. Every smart contract becomes a massive honeypot, accumulating user funds in one centralized location for attackers to target. The Anoma resource machine, or ARM, approaches digital physics from the opposite direction. It completely discards the concept of a shared smart contract ledger. Operating on the EVM is like trusting your bank's internal database to keep track of your money. Operating on the ARM is like holding a physical $20 bill in your own pocket. Watch how this structure changes. The old ledger breaks apart into discrete, localized digital objects Anoma calls resources. By isolating these objects within your private environment, the overarching smart contract is physically removed, eliminating the centralized master pool. True digital ownership requires holding the asset object itself. When you eliminate the shared ledger, you eliminate the risk of a centralized ledger hack. Without a central smart contract to process trades, the Anoma network relies on a mechanism called declarative intents. Instead of signing an imperative step-by-step process of how to execute a trade, you sign a strict, non-negotiable declaration of exactly what outcome you require. This scale illustrates the logic. You destroy an input resource on one side only if your exact required output is created on the other. This mathematical rule is balancing to zero. Transactions finalize only when consumed resources perfectly match created resources, balancing the scale. By forcing the transaction math to balance atomically, the system guarantees you receive the exact outcome you demanded. If the math does not balance perfectly, absolutely nothing happens. This architecture creates an immediate roadblock for anyone attempting to exploit a transaction. Because there is no step-by-step execution trace broadcast to the network, a hacker has no middle process to intercept or manipulate. Here we see the scale mechanism again, but an attacker tries to deliver an incorrect output resource. The balancing to zero equation mathematically fails to balance, and the network immediately triggers a hard rejection of the entire trade. Your intent functions as an unbreakable cryptographic lock. Your security no longer depends on trusting a developer to write perfect code. It relies entirely on pure, incorruptible mathematics. Anoma applies these resource principles to function as a distributed operating system. This system unifies disparate blockchains and hardware into a single interface. It allows developers to write multi-user applications that run across a distributed network of computers as if they were a single machine. Because assets are held locally rather than on a global master list, the network scales through fractal instances. Fractal instances are independent versions of the protocol that can be deployed by different communities while remaining connected. This allows users to move value between different security domains without losing privacy. The next generation of digital finance doesn't require writing safer smart contracts. It requires an operating system where you never have to hand over your money to a contract in the first place.